Um, okay, so I guess I'm going to talk about effort force. And so, consider the Egyptians. They needed to move these great big, huge, massive blocks. And they needed to lift them, but they were really, really, really heavy. So when they built the pyramids, they had to lift these very heavy rocks, or bricks, I guess. And let's assume, I'm just going to put a number on there. Let's assume the weight of these things were 100 newtons. And so, essentially what they needed to do is they needed to lift 100 newtons, which isn't a very big block, but let's assume they needed to lift it 5 meters. So the amount of work that they needed to do was equal to the force, all right, the force that they needed to exert on the object times the distance they needed to move it. That's what the physics definition of work is. It's force times distance, okay? So they needed to take 100 times 5, which is 500, and the unit for work is joules. So it's 500 newton meters, or 500 joules. So that's how much work they had to do. Well, the cool thing about a simple machine is that no matter how we get that block up there, the work is always going to be equal to the force times the distance. Okay? So if we lifted it straight off the ground and we lifted it 5 meters straight into the air, it would take 500 joules of work. All right? But, and sometimes we call that output work. But that's what it would take. I mean, if we tried to lift that thing, it would take 500 joules of work. But what if we slid it up an inclined plane? All right? It doesn't really matter how we get it to this plateau of 5 meters above the ground. So if I were to slide it up this inclined plane, and let's assume that the inclined plane was actually, instead of 5 meters, let's assume that it was 25 meters. Well, if the inclined plane was 25 meters, what I'm doing is I'm changing the amount of distance. But the work it takes to move that block 5 meters in the air is still going to equal the force times the distance. Okay? So then my force times my distance, because I've changed the distance, requires less force. In other words, I'm still going to have to do 500 joules worth of work, right? Assuming that there's no friction on the surface of the inclined plane. And if I move at a distance of 25 meters, then the force I would need would be a lot lower. In fact, the force would be less than 100 newtons. It would actually be 20 newtons. And so that force, because it's smaller, and sometimes we refer to that force that we use, it's known as an effort force. Right? That's the amount of effort we have to put forth. We still do the same amount of work, but we use less force to push the block. Okay? And so because we're using a simple machine, the work that we do is the same, but the amount of force is lessened. And we call that effort force. So a simple machine, really in essence, takes less effort to move something, especially in this case of an inclined plane. All right? So the simple machine requires less work, no, less effort. The work is still the same, it just requires less effort. And that's it. That's effort and work and force and simple machines. Thanks.